So in this tutorial, we're going to be looking at the thermodynamics simulation. So we start by clicking on thermodynamics, and when it brings up, you're going to see three different choices for variables. You have your mass in kilograms, the initial temperature in degrees Celsius, so we have it set at negative 100, and then what's your flow of kilojoules per second. So you can put whatever values in you want, and then we're going to hit simulate. And so what you see here is the simulation has on one side, you have the pictorial representation of the ice cubes in the beaker being at negative 100, so water is going to be in the solid phase. But yet we also have a molecular composition and representation here. And so when I turn it a little bit more, what we're going to get is a chart of temperature versus time. Now I can click on the buttons here, and it shows me the speed of the simulation. So I like ramping up the speed a little bit. You can if you want to, you don't necessarily have to. And then I'm going to hit simulate. So what happens is you see the graph is starting to collect data at real time. You see the molecules are just starting to move a little bit, and nothing is really happening with the ice. But if you look at the top, you get your temperature in Kelvin. And so what's going to happen pretty soon is you see that the temperature flatlined. And so when I look at the graph, that's what we see happening is the temperature is remaining constant, but we see that when we look at the ice, what's happening is we're undergoing the phase change. So the ice is melting into liquid water, and once all of the ice melts, what you're going to see is that you're going to see the chart start to go back up fairly soon, and you see the temperature starting to rise. So you can again look at it from a molecular standpoint, the pictorial representation of it, as well as the graphical representation of a thermodynamic process.